We begin now our exploration of interval estimation in Chapter 7. So when we say interval estimation, let's break that down. So interval refers to a range of values. In other words, we're not pinpointing an exact value that we're looking at. Say, we are assuming that our mean is going to be exactly 7, but we're going to give it, maybe between 6 and 8, right? An estimation refers to the fact that we're approximating, or that we are using and inferring our knowledge, using our available information to, I guess one could say guess or infer. So there's a natural amount of error that's going to be involved here, and we'll talk about that at length. But the most common and the only form of interval estimation that we discuss here is the notion of a confidence interval. We actually encounter confidence intervals quite a bit in our day-to-day lives. We use them quite a bit when we use polling to determine public opinion about certain subjects. And the important thing to note here is that this is a range of methods, or a set of methods, I should say, that seek to estimate some parameter. And we'll be using the power of the sampling distributions that we discovered and explored in Chapter 6. So it all builds on itself. To motivate this, let's talk about an example, notably from the social sciences. One very popular but often misunderstood experiment in psychology. So in early childhood psychology, a famous study goes by the name of the marshmallow test. In fact, it's so popular that it's also sometimes shorthand for when somebody doesn't have the patience to carry out some objective. It indicates something about their intellect. So, in short, and somebody else can explain it far, far better than I can, but I'll do my best here. It was conducted originally with a group of children where the children were offered two options. One indicated impatience and one indicated restraint. The impatient child would be the one to eat the marshmallow immediately. And a marshmallow would be offered by the experimenters. And the children with restraint would not eat the marshmallow right away. They'd have to wait 5 minutes or some short period of time before the experimenters came back and promised a second marshmallow. So, in other words, if they eat the marshmallow, they don't get the second marshmallow, but if they wait 5 minutes, then they get 2. From a purely decision-making perspective, one might think, well, it's a short amount of time, just wait, then you can get 2. It's better than the option where you eat the marshmallow immediately. So the question here is, because this is based on a sample, we get a sample proportion, denoted p hat, of the number of children who wait for the second marshmallow divided by the sample size, the number of children in the study after all. And this might be an interesting way of estimating not only the population proportion of this exact experiment, if this was conducted with every child in a population, but also it could be an indicator of the number of children who have greater success in life later on. There is recent research, however, that suggests that this is not the full picture, that there's actually several confounding factors in the design of this experiment that suggests that socioeconomic factors may be more responsible for the difference between the children who exercise restraint and the ones who exhibit impatience. So we'll talk about that at length. What are our objectives this chapter? So first, we're going to determine and analyze confidence intervals, namely we're going to be looking at three different cases, one with proportions, one with means, and one with standard deviations. 2, we'll be able to determine a minimum sample size. Needed to guarantee a maximum margin of error, which we will make precise in coming sections. And 3, we'll learn how to use bootstrapping, which is a technique unlike the ones that we examined in the first half of the chapter, to determine confidence intervals. And these are the 3 objectives that we'll work on throughout this chapter.